Are you all ready? Yeah. You ready to do some analytics? That'll never work. No. All right. Hi, everyone. Thanks for coming. I really appreciate it. So talk today, turn your game up to 11, Unity Analytics and Data Science. If you understand the derivation of that name, you've just dated yourself. You have to be of our vintage to get that. But I'm Marc Tanenbaum. I am an engineer and product manager at Unity Analytics.
And I'm Dr. Luke Dicken. I am Director of Central and Strategic Analytics at Zynga.
It's a very cool title. I like that title.
It's been 2 weeks and it's not really settled in.
So just to give you some sense of like who we are beyond just the titles, I've been in the games industry for, I don't know, about 15, 16 years. A lot of indie titles, some mid-tier stuff. And so I've kind of been in the trenches well before I came to Unity. And once I got to Unity, I came into the analytics team not knowing a lot about analytics. And I suspect there may be one or two people in this room who are in that same boat. Like you're good at your job, but maybe analytics is something you're just coming to. And so my part of the talk is actually going to be a lot about about kind of some introduction stuff, some things just to help you get started. And Luke, why don't you talk a bit about yourself and then how your bit fits into that?
Sure. So my background is in AI. I have 3 degrees in theoretical kind of AI. And then my PhD was specifically in AI for games. And then Zynga said, hey, we'd like you to come to San Francisco and do some data science. And I was like, I don't fucking know what data science is, but sure. So I did that for the last 3 years. But kind of as I was working through my PhD, I was kind of doing a lot of AI contract work for hire kind of stuff, assisting the industry, and kind of becoming this game AI guy on top of a bunch of work with the IGDA and the IGDA Foundation. So like Mark, I've been kicking around the industry for a while, but not really kind of necessarily deep in the trenches in the same way that he was for a while. And now I'm at Zynga, but centrally. So even that doesn't count. I don't get to ship stuff. I just get to do tech. And what we'll be talking about on my half of the talk is kind of how you can kind of join the dots from Unity Analytics into some kind of more, am I allowed to say more advanced?
Please.
Okay, more advanced kind of techniques to kind of go beyond what the initial dashboards are going to give you.
Great.
So with that, I think you're going to just get started.
Let's do it. Okay, so my half of the talk essentially is Unity Analytics in you, and all that is to say is understanding what the tool we have is about and how it can help you. So let's just jump right into that. So let's start with the fact that I have to sit at this podium. I promised I'd stay here. I like to walk around, so I feel a little constrained. Plus, I've got these excellent socks that I wanted you to see. What are you going to do? But back to analytics. So what is analytics about? Why do you care? The reason you care is you pour your heart and soul, your blood, sweat, and tears into making a game. You put it out into the world, you might want to know how it's doing. Fair enough? So if you think about all this energy you throw into what you do, and then something goes out into the world and maybe you see your sales numbers, or you see, you get some information from iOS or from Google, and it gives you something, but it doesn't necessarily dig into the why. Like, what's really going on with my players? And that's really important. So analytics essentially is the dashboard of your game. It is how you know how it's doing, why hopefully it's doing that, and gets you on to being able to do something about it. So this is the way we think at Unity Analytics, the way we think about analytics in a nutshell. It's something that we would like if you walk away with one thing from this talk, it's probably going to be from Luke's part. But if you walk away from anything else, I'd really love you to remember this. We call it the loop. It's a very inspired name, but it simply means that the live cycle of your game is not a static thing. You don't release a game to the world and then walk away. You don't even release it, look for data, and then go, that's really interesting. My game's doing great, I'm so happy. What you do is you collect data, you analyze the data, and then you do something about it. If you're not doing anything about it, you're kind of missing the best part, right? In fact, you're kind of missing the only part that matters, because what difference does it make if you're not actually learning and doing more with what you've done? So it's a cycle. You wash, rinse, and repeat. Keep doing it until you've got the game as tuned as you can make it, and then tune it some more. All right? So let's get into that in some specifics. The first thing is, so in the area of collection, I'm going to spend a little time on what it takes to collect data in Unity Analytics. And the first thing is simply to turn it on. You may have seen this before. If not, I'm going to show you very quickly. So here I am. I've got a new project that I'm about to spin up. Now, you can just turn it on. Like, if I leave this on, you're done. You don't need to do anything else in terms of just getting it activated. But I'm going to deliberately not turn that on. I'm going to create a project, because many of you may have an existing project that you maybe would like to turn analytics on for. And once this finishes with I never understood why we have a HoloLens DLL opening on a blank project. I'm sure that makes sense to somebody. So waiting, here we go. Okay, so you go to this little cloud button, or you can go to Window Services. Either one of those goes to the same place. It opens my services panel. And if the gods of the internet are with me, and they sometimes aren't at conferences, come on, services panel. This happens every time. Only when I present, right? It works perfectly up to the moment I present. Here we go. And of course, it didn't do nothing. Okay, I'm going to have to set this up. Fun. Okay, so I create it. Okay, so now I got my services panel. I click on the analytics tab, and there's a similar looking button that's going to show up here any second now, internet. You're going to work with me. You're going to work with me. I'm hardwired to the internet and everything. Let's try reloading. It's so easy to set up Unity Analytics. There it is. Okay. So when the internet, at your home where I assume your internet actually works, it's really fine. So there we go. What's that? Okay. All right, so there you go. Boom, you're done. Analytics is happening, okay? So that's all it is. Other than the internet problem, you can see it. It's just basically clicking a switch. So, okay, let me go back here. So we start with turning it on. What does that do, turning it on? Turning it on starts giving you information like, when do people show up? How often do they return? What country are they coming from? What device are they on? Stuff like that. I would call it very surface level analytics. Very useful, super important, but here's the thing. None of that tells you anything about your game, right? How often people come back, what country they're coming from. That's the same as you would get for a website or a mobile app, right? So custom events is how we get to the things about your game. And you can do anything in custom events. It's a simple line of code. You can see some examples I've written here. Screen visits, store opened. Is it politically incorrect to say I ate a penguin in Australia? I felt like that might be a little risky. Anyway, so you can do that, and then you can even add, I've shown an example where you can even add custom parameters. You throw a dictionary together, and was the penguin delicious? You be the judge. So custom events allow you to give more information about specific game things, and I'll show you in a few minutes like an example of how you put that to use. But here's the thing. We looked at our data. We get a lot of data, a huge amount of data. You heard what was the number? Like 2 billion downloads, something. Anyway, a lot of data coming into us. We've looked at that data, and what we've realized is about 90% of the custom events are actually all the same. They are variations on level start, level complete, a store was opened, a social share occurred, some economy thing happened, like you acquired an item or you spent an item, a screen visit, like all these things, they just happen over and over and over. And we're like, wait a minute, why do we make people actually, we talk to people and realize they're spending a lot of time figuring out which events to cover. And they're all doing the same things over and over. So we just packaged it up. It's in the asset store now. It's called Standard Events. In 2017.3, it will be standard built in. And you'll just have all these events. And the nice thing is, the new syntax, it's like analytics event dot, and then thanks to the miracle of code complete, it'll just tell you the list of things. And you can still do custom things, but it's just easier to have all the list in front of you. Plus, we've figured out for each one of those events specifically the information that you should probably have in there. So like for a level complete, might make sense to have an identifier. So it can be a string or a number, and you can still put custom parameters into those standard events. So, and I'll show you why that's useful in just a second. Okay, so moving on. Analyze data. We have a lot of ways to analyze data, way more than I have time to get into in the relatively brief amount of time I have with you. I'm going to briefly mention that we have ways that you can look at those, the number of people coming back I spoke about, that's the retention rates or your new users. We have ways you can look at your custom and your standard events. For people who have Unity Plus, we've got this live stream which lets you see where in the world different events are happening right away. It's cool. But the one I'm going to focus in on is funnels, which is the one in the middle here. Now, who in this room knows what I mean when I say a funnel from an analytics perspective? Okay, quite a lot of people not raising their hands. So quick idea of what a funnel is. Has everyone here seen a kitchen funnel? Right? Big at the top, small at the bottom. Really simple. In analytics or any kind of flow, it doesn't have to be technically analytics, all the users go in at the top, you move to the next step, maybe not all of them made it to the next step. Another step, maybe they didn't all make it. Another one, another one, another one. You get a funnel, and you can kind of see that shape in there, right? On the left, everyone's in there. On the right, not as many people. The idea is, in a flow of most sorts, you might imagine things like level completion or onboarding or purchasing through your store, that you'd expect not everybody to make it through. Like not everyone who walks into the store is going to make a purchase, right? And so you have a natural degradation. What you're looking for are places maybe where there are big drop-offs, because those are places where you can probably optimize and fix something. So I'm going to go to a very practical demonstration of this. I want to show you a funnel from these guys. Okay, so this is Dragon Boom by Ankama Studios in France. Really good game, a really fun arcadey game. You play a baby dragon that kind of is learning its way into breathing fire and things. They're great game makers, a little bit noob when it comes to the analytics world. So they found standard events, they implemented a bunch of stuff, and it immediately occurred to them, because we kind of suggested it in the events themselves, that they should create a funnel. So let's look at their funnel. So this is real data. It's a little old because I've cached it locally because I anticipated the internet problem. But as you can see in their funnel, mostly it's actually really nice. If you know how to read a funnel, this is actually a pretty good funnel. There's a gradual drop off right the way along through the levels. They're all level completions, except the first one. The first one is tutorial completion. And you'll notice there's actually, percentage-wise, a pretty big drop off there. So the lesson that they might pull away with that is, oh, there may be a problem with our tutorial. There's some disconnect between people completing the tutorial and people completing the first level. We might want to investigate and see. Maybe there's something we could tweak or tune, or maybe we can even remove the tutorial. But otherwise, they've got this really nice funnel. Looks great. But I mentioned to you guys how standard events can have custom parameters. So let me show you what that looks like. These guys took our standard events, the standard event level complete. The only thing it requires is a level identifier. So that's what allows us to build the funnel. But they added gold collected. Now, is anyone in this room astute enough to tell me why this alarms me, what I see here? Any guesses? Come on. Yeah, what about those peak spots?
Exploitations?
Bingo. There are specific levels in this game that people are mining for gold, which could affect your game economy, which could ultimately affect your income. Because if your game economy is somehow tied to need to purchase, right, things get thrown out of whack. So people start doing that. Now, let me go one level deeper. I'm going to get rid of this conversion line for a second, and I'm going to do the collected gold again. This time, though, I'm going to go to Japan, and let's see what happens. Yeah. Raise your hand if you don't understand why that scares the crap out of me. Okay, so just to give you an idea, this is why funnels are really powerful, why the standard events feed into it, and why having the ability to put your custom parameters into the standard events is such a good idea, right? Is that very clear, like why this all makes sense? Okay, awesome. Let's go back to my slides. So do a little time check here. Okay. So moving forward. Okay, I don't have time, unfortunately, to do a demo of this, but I wrote this system personally, so anybody wants a demo of it, I will walk you to a table and we can talk about it later. But heat maps is a really cool plugin that we have. Again, it's in the asset store. And basically what this does is it allows you to plot space and then do a heat map on that space. So in the top image, what you're seeing is basically just where players went. And where they went a lot, it's red, and where they went a little, not very much, it's green. And it just gives you a way to go, oh, okay, my players are going here and they're not going here. And you find choke points. You can plot it. By the way, it doesn't have to be where they went. It can be where they scored kills. It could be where they jumped, where enemies died, anything you want. Basically, it's just a custom event wrapped in a special, in a shell that makes it make sense to the heat map system. So it's super easy. You can even add custom parameters to those heat map events, and that's what we've done on this bottom one. We added a custom parameter on these called FPS, and then we recolored the map. And can you see there's an area of red, right? What is that telling me? It's telling me that I'm heat mapping a low FPS area. So if you got a game, you're worried there's a performance thing, or maybe you just want to. Maybe you could put collected gold in there and see how much gold is being collected in certain spots. You can use the heat map system to uncover those sorts of pieces of information. Anyway, so that's another way to analyze. Now, the last area that I'm going to get into is doing something about it, right? We have this loop. We collect, we analyze, and then we act. Now, one way to act would be to go back to your engineers and your artists and your game designers and say, okay, we need to take the gold that's being mined out of the system. We need to rewrite things and whatever, re-release. You go to the App Store. 2 weeks, 3 weeks later, you've got a new release. You could do that, and for a lot of things, you will have to. Remote settings is a way to tell you don't always have to. What remote settings does is it allows you to set up variables that can be controlled from our servers. So, what could you control? Well, I could set a Boolean that just says, hey, this thing is true or this thing is false. And then I read it in code, and in code I say, if it's true, start with the door open. If it's false, start with the door closed. Something like that. I could change a string, and I will show you an example of that in a second, and have that string read out or consumed somehow. Or I could do numbers. I can even do a blob of JSON, and you'll have to interpret it yourself on the inside, but that's not that hard. So you could actually do rather more complicated sets we will treat that as a string, and you can do some stuff with that. You can get 200 keys and values into the remote settings system. You can also segment, and I mentioned this, I don't know if you all caught this in the keynote this morning, but you can now do segmentation on your variables. And what that means is that I could serve up one set of values for, say, the Australian audience, and a different set of values for the American audience, or the Chinese audience, or whoever. Our segmentation system is really, really powerful. You can do it based on some custom event you sent. You can do it based on monetization factors. You can do it based on platform. So there's a whole slew. I haven't even gotten close to listing all the various things you can segment on, and you can combine them. So for example, I could say, people who spent money on iOS in Australia who passed level 10. I could create a segment like that, and if that turned out to be a useful segment to you, you could do something about it. And now with remote settings, not only could you create that segment, but you could serve up stuff based on that segment. So maybe you want to serve up stuff, different things for people in certain areas or whatever. Make sense? Let me show you a quick example of this, and I'm going to show you a little code as well, just so you can see it happen. So here's okay, go to my development version. Make sure that works. Once again, I'm going to be relying on internet, so if you believe in prayer, say a little prayer for me. Come on, baby. There we go. Okay. Did somebody say something about the Australian internet? That can't be true. You guys must have good internet here. Okay, I'm more optimistic than you. Okay, so you see this, I got this thing called seasonal theme Halloween. I'm going to go to my game here. This is a game from our friends Dr. Panda. They're in China. And this cute game is showing Halloween-y things. Isn't that great? Okay, we're coming up to Halloween, you know, it's nice to have it. So the way this works is they shipped a binary, and the binary had some Halloween things in it. But because they didn't want to have to do a re-release for Christmas, because a lot of people might not download the re-release, they also shipped it with some Christmas stuff, and Christmas is coming up. So I'm going to stop this. I'm going to go back here. I'm going to change our seasonal theme to Christmas. Save, sync. Okay, now, let's see. Sync to finish. Come on, there you go. Okay, so if the internet's with me, come on, baby. Yes! So there we go. So we have a Christmas theme, right? Now, just to give you a sense, obviously relies on the internet, clearly. What will happen if your customer doesn't have an internet connection is it'll take the last cached version of the data. So it's not like the game will break or anything. It'll just, they may get an older version of the data until the next time they are connected. All right? And this, by the way, will happen on startup. You can also force it, and I'll show you very quickly how that works. So here's some code. Let's zoom in here for a second. Just to show you how this works. So basically, there's a remote settings API, and you can ask. It's very like you've seen an API. If you do any programming at all, you've seen APIs like this in Unity before. So you know, is there a key called seasonal theme? And if there is, we say get string. You can say get int, get float, get bool, and then it just applies it. So as long as you've done the wiring, it's really straightforward. I did mention that you can tell it to update, and the case for that might be, let's say you had a big open world kind of thing, and you wanted to make sure that every now and again you check to make sure, because players may be playing for a long time, like in a mobile game, maybe, most mobile, maybe you wouldn't do this, but the case may come up, and to the extent that it did, I'll just show you here, remote settings dot force update, right? And now, boom, it will force an update for you. So you can do that during the play if you want to. But by default, it just does it at startup. Okay, so with that, I just have one last thing that I want to talk to you guys about. It's called raw data. It's raw. Raw. No, seriously, it's raw. So raw data is what Luke's going to get into. But just as a way to key it up and tell you, so this is a Unity Pro thing. There is a sort of sneaky way to get it if you don't have Pro. So if you really, really like what Luke talks about and you want to know the sneaky way, come ask me afterwards. But the idea of raw data is your game just sends us events. And we take those and we process them. And that's what shows up as funnels. And it's what shows up on the Data Explorer. And it's, you know, these various tools I've been showing you, it's all goes through the what we call Blender, which is our aggregation system. But at some point in their lives, they were just a bunch of individual events. And those individual events have meaning to them and allow you to do other things that we haven't supplied you with tooling for. Right? So it really lets you dig in a bigger, deeper, more interesting way. So that, Luke, is your cue. Yeah, maybe you should. So Luke's going to tell you about how we're going to kick it up a notch. So, let me hand this over to you.
Okay. Alrighty. So now we're going to go from all the kind of bog standard stuff that Mark's just been talking about. We're going to go all the way now to 11. So, what is data science? So, Mark's been talking about analysis. He's been talking about analytics, which is kind of the name of his job. Analytics tells you what happened in your game in the past. It's the actual what happened of this stuff. And we can highlight concerns that have happened in the past. So, Mark highlighted that there was a level that was giving people too much gold. Great. Now what? So data science is kind of how we go beyond that. So with data science techniques, we could automatically detect that and correct for it. But it's also about gaining additional insights, gaining more of an insight into what's happening in the game, what we expect to happen next week. You know, trying to think more about taking the vision of the past that analytics gives you and generalizing that into maybe even why things are happening rather than just what's happening. And to shamelessly steal Mark's little graphic here, what it's really about is supercharging that loop. And kind of really getting it not just supercharged, but also in some places automated. So let me move my mouse so that I don't have this little thingy on the screen. Oh, so well. Cool. Low-hanging fruit with data science. The thing is that once we can take the raw data out of Unity, we can do whatever the fuck we want with it. It's great. It's actually a really powerful system. So we can do things like predict what players are going to do. And when we say predict what they're going to do, that might be who's likely to pay for something in this game. And we can build a model by evaluating the past and what happened next. We can look at what's happened recently and predict what will happen in the future. And we can give people a score that's like, how likely are you to pay for this thing based on what we've seen people who are like you do in the past. How likely are you to leave the game is also an important one. How, you know, people who have behaved like you, like lost for the last 10 games straight, don't come back. So maybe we give you an easy match next so that you win, and we can break the trend. But it's not just about that. It's not just about predicting the future. It's also about deeper understanding. So, you know, let's talk about gaining a deeper understanding of our player base using data science. So bottle player types are a fairly standard way of thinking about the types of players that we have in games. We have achievers, explorers, socializers, and killers. And this was a thing that Richard Bartle came up with. I'm not going to give a number because he wouldn't like me knowing that he's been around this long. He's actually expanded it, and there's a lot of different subtypes these days. But this is the good extra credits graphic to steal that shows the 4 key ones. So we kind of have on the design side, we can kind of say, okay, we think that there are like these 4 categories of players. Great. How is that helpful? You know, thinking that there are 4 categories of players for a start doesn't mean that there are 4 categories of players. One of the things that I think anybody who's worked on a live game before has come to is like, you sit in a design meeting and you have this great vision of how it's all going to work. And you've got this amazing game, and you know exactly how everybody's going to play it. You know exactly how the game's going to work. It's all going to be great. And then you put it out into the world, and what is the actual chance that it works exactly the way that you expect it to? Well, so I heard 0 from the room, and that's actually a lot less charitable than I was going to be, but it's about right. You know, we have a belief about how people will play our games, but that doesn't mean that we're right. And using these kinds of techniques that I'm going to show you today, you can actually go and find out who's in your game, whether the people who you think are in there, the kind of stereotypes that you think are there, are actually there. And then you can start identifying the people, figuring out what type they fit into, and then you can use a tool like remote settings to go back, say, okay, this is what these types of people look like in the data. Give them this experience. Give the achievers more things to chase. Give the socializers more opportunity to interact with people. So when we think about player types, we need to get away from nouns, because nouns aren't helpful to us. We need to start talking in terms of verbs, because verbs are what the analytics are going to be tracking. You know, people did this, people did that. It's not tracking, this is this kind of player. So we need to kind of start to build up a picture of what we think these player types might look like, because that's going to help us as we kind of start looking into the data and trying to figure out where to be. And since somebody's taken a picture of this slide, I should note that this one is stolen from Amy Jo Kim, who is a kind of gamification and game designer in San Francisco. All right, so if we're going to be chasing this kind of stuff, then we need to figure out how to do an analysis around this. And maybe the next slide is going to tell you how to do that. Yes, it is. Excellent. So clustering is the mathematical term for what we're going to be doing today. And in this example, there are two dimensions to our data set, and there are clear segments there in the data, and it's really easy to figure out where our player types are and give them something to do that will feed back into the segmentation. It's never going to be this easy. Two-dimensional data kind of doesn't exist. The data that we're going to be playing with today is 200 dimensions, and that is 1 week of data, one event. So that is the level complete event for the same game that Mark was talking about. We typically think in terms of like 500 plus dimensions when we're doing this kind of analysis. But the nice thing about it is that because it's all automated in code, it doesn't matter. All it really changes is the amount of time that you're going to be able to go take a coffee break before the thing comes back with an answer. So I'm going to show you a code demo. It's not a long code demo. We're going to be doing this today in Jupyter. Jupyter is a really powerful tool for data science based around what's called a notebook. And a notebook allows you to do code and mark down and display results all in line. So that's why data scientists like it. I started using it a few months ago, having been very reluctant because I feel like if you're going to do code, you should use an IDE like a real developer. But it turns out it's actually really good. So no need to kind of take a photo of this, no need to copy it down. It's all hosted in Git. We'll be making the link available at the end. You'll be able to take this away and play with it yourself. But we're going to use pandas, which is a Python library for data processing and stuff like that. We're going to be using scikit-learn. And then we're not actually going to use this today, but I've written a little importer that will take raw data from Unity and make it into a usable file format, because theirs kind of isn't. So that would be those lines there. But we commented them out because it takes a little bit of time to run. Mark gave me 1.2 gigabytes of data. I'm not going to try and number crunch that live for you today. Instead, what I've done is I've cached it out to a CSV, and we're going to load that in and read it just now. And the nice thing about this kind of thing is, Mark's been talking about custom events and the custom parameters that you can put on even standard events. So what we've ended up with here, and it has loaded the CSV in, is we've got user ID, we've got the level number that got completed, so that is the index that is required for a level complete event. And then we've got the duration, which I guess is the amount of time it took to complete the level, number of defeated enemies, amount of gold collected, and the remaining lives for that user for completing that level. Simple, straightforward kind of stuff. The problem that we've got here is that this is a counter-centric view, right? We're looking at it in terms of the individual levels. And what we're trying to get to today is understanding users. So we need to reframe this data a little bit. And what we're going to do is we're going to use these lines here, and just another 5 lines of code. That's all this is going to take. And what we're going to get is we're going to turn it from being a bunch of counters that have been logged on the level complete to a bunch of users with the numbers that they got for every level. There's 50 levels. There's 4 different counters. That's how we get to a 200-dimension data set. I should really have been running that while I was doing all that spiel. So what we're doing is we're actually here. We're going to aggregate everything together here into indexed by user ID and level complete, and we're going to average together all the duplicates, because there are some places where people have played the same level twice, and therefore they've logged the counter twice. So we're going to take the average of those, and then here what we're going to do is we're actually just going to create a data frame that is the unique UIDs. So we're going to aggregate it by user ID. We're going to drop all the extraneous stuff that we don't actually care about, and then we're going to reset the index because we don't care about that. Still not all the way there. So what we need to do next is reformulate that data. So what we're going to do is for every level, we're going to say, okay, we've got the list of unique user IDs. We've got all the levels and the indexes, the level indexes and the user IDs. We're going to take that data, we're going to slap it into this thing, and we're going to build out that broad data set of level 1, this, and this. And in fact, it's done already. So level 1, duration. level 1 defeated enemies, level 1 collected gold, and et cetera, all the way over on the right-hand side, we've got up to 50. And because we want to understand users in general, don't need to keep the user IDs anymore. Throw them out, they're gone. So that is our data. It's now ready to be clustered. We can kick it out to a CSV. In fact, let us just take advantage of that for a minute. So before we cluster it, what we have here is what this data looks like. So it's always good to dive in and take a look at the data before you start. Mark, as I said, 1.2 gigabytes, that's about 2.5 million events that got logged. I've trimmed out the outliers here, but this is why it looks like a mess of nonsense. It's colored by what level people are, and it's highlighting the average duration versus the average gold collected. And really, what I'm trying to show you with this is that it's a kind of mess of bullshit. There's no real rhyme or reason. There's so much data that you can't kind of visualize it and see what is actually going on. And while I'm here, this is a great tool, by the way. This is Tableau. Fantastic tool for visualization. It's $35 a month per seat. I don't get a kickback, but I do think that it's actually a really good investment because you can do all sorts of visualization tools like funnels, for example. So anytime you're taking that raw data down, being able to just visualize it really quick is great. And for my money, you might try and do this in Excel, and you could get away with it maybe. But to be honest, for $35 a month, you're going to get the value out of having something like Tableau available. So we have, so that was user level data here that I was showing you. Here we've aggregated that up to just be averages per level. And you can kind of start to see some patterns in the data, but what we'll do is we'll run these 3 lines of code. And these 3 lines are going to find 20 clusters for us, and they're going to output what those clusters are. The reason that we're chasing 20 is that there's a whole bunch of outliers in that data. So let me just show you what that looks like. So if I kill off these exclusions, it'll take a minute to load it up, so we'll probably just come back to that. But what you're going to find is that there are some crazy outliers, and a lot of that is kind of the stuff that Mark already kind of showed in the funnel. The funnel is one view on it. This is giving you a different view, where you've got these things that are like, these numbers are kind of in the hundreds, thousands maybe. Somebody makes 10 million, and you try and visualize the whole thing, and you've just got one data point all the way up here, and then a tiny little bit where everybody else is. That's why we're chasing 20 clusters here. So there's a few things we could have done. We could have tried to remove those outliers. It's not very easy. So we're chasing 20 clusters, because what we're going to get is we're going to get a cluster. There we go. We're going to get a cluster that's one person. We're going to get a bunch of clusters, in fact, that are one person. And then we're going to have a kind of breakdown of where the other people are. But you can see here that we've got a few people up here, a few people out here, and that we were looking at is actually basically just this little area here. So start that running, and like I say, it's 3 lines of code. And one of the things that I think is really important to be aware of is most of this stuff is not super intensive. Most of it is fairly easy to write. Most of it, in fact, most of this, you can copy off Stack Overflow. Coming into this, I can't say I didn't know how to do this. I knew the keywords that I needed to search in order to get this put together. Putting this notebook together probably took me a few hours. It's not particularly rocket science. And running it across, I think we're down to, because we're taking a user-centric view, we're something like 170,000 users in this data set. So that is now clustered. And to prove it, we'll just stitch it back onto our data set that we had before, which actually is one of the more intensive pieces of this thing, and I don't understand why. But what this is going to show us is that we're going to have all that user information that we had with different cluster indexes. And that's going to say which cluster those people belong to. So same data that we had before, 1, 2, 3 for all the different things. And then over on the right-hand side, we've got cluster. And we've got a whole bunch of numbers here that are which cluster those people belong to. So visualizing that, again, doesn't necessarily make sense because in 20 dimensions, trying to find where those cuts are and trying to think of it in terms of that diagram I showed earlier, where there's a group here, a group here, a group here, It makes sense in a 20-dimensional space, but I can't visualize that in my head, and I'm not going to try. So it's colored here now by what cluster people are in. And you can see that there's a whole bunch of, I don't want to change the color. So there's a whole bunch of people over there. The sort of light bluish people kind of appear in a bunch of different quadrants here. But that's only a 1. There we go. Those people are appearing in a whole bunch of quadrants. On different dimensions, they're going to be in different areas, and that's what is creating that clustering. Okay, so we've clustered all the players together. So what? So the next thing is taking that and putting it back into Unity. So we're going to do that, or we would do that. I'm not going to try and do it live. But the way that we would do it is through the segmentation tool that Mark talked about. So we now have this in terms of parameters that are already logged into Unity Analytics. We know where those cuts need to be across all the different level complete counters. So level complete 1, if gold collected is less than this, and this, and this, and this, and this, and this, and this is a segment now. So we've used this clustering tool to define what those segments can be. We can put that into the segmentation tool for Unity, and then we can wire it all together with remote settings. And that is where we're taking that loop and making it this turbocharged thing. So that's it for the code demo. Like I say, this is going to be available on GitHub. It probably needs a little bit of a polish up from where it is right now, but we'll make that available this afternoon. And the link will be at the end of the slides. Couple of things just to be aware of before we close out. One of the things that is a common technique in data science is this thing called dimensionality reduction. What that basically is so imagine this data set, and you have it as a 2-dimensional data set on the X and Y axis. That's not what I wanted to do. But really, given the shape of this data, you could actually capture it as a 1-dimensional data set that runs kind of diagonally. And that would allow you to smush 2 dimensions down to 1 dimension. I mean, this is a really standard technique that a lot of people use. It allows you to take your 200 dimensions and reduce it to something way more manageable. The reason that we didn't do that, and this is something to be very conscious of when you're dealing with the Unity ecosystem, is we need it to be in terms of those original counters and the original parameters that were logged around those counters in order for it to work with a segmentation tool. If you recast it to a whole bunch of new dimensions, Unity doesn't know what those dimensions are, and you can't kind of get set up with like any way of translating between the two. So that's why we did a very specific thing here, and we didn't do some things that if you are a data scientist or you know about data science, you might be thinking, why didn't they do this? This is why, and this is why as you're kind of doing the analysis yourself, as you're taking this forward, which I'm assuming you all will, just be aware of that. And the final thing is this note on big data versus small data. So coming from Zynga, it's really easy for me to kind of stand here and say, oh, data science is the way forward, data science is the thing to do. Words with Friends has about 6 million daily active users. Across our entire portfolio, we're talking about like 19 million daily active users. Most games are kind of not that large, and that kind of gives us a very unique and skewed view of things. So we were talking about a game where in 1 week there were 160,000 users logging stats. There were 2.5 million level completes. So it's a kind of an order of magnitude, if not 2, below kind of where we normally play. It's okay. You don't, the thing about big data is that there's a lot of people spend a lot of time ranting and raving about how big the data needs to be. And big means that you have confidence. Big means that you have statistical significance. But small data is actually usable as well. And one of the things that I've been doing prior to my current gig, I spent 18 months kind of doing new concept development for Zynga. One of the things that I found very powerful in that is this idea that we can test and log analytics during development when there's only 5 of us playing. Being able to kind of use that information is really great. It's not giving you statistically significant, I have confidence in this, my data is authoritative, this is what we need to do to fix the game. What it's going to give you is something that's a lot more directional, but that's okay. You can have directionality and guidance from data just because, you have data. And effectively, you can think of it as telemetry, which is another word for analytics in some ways. When you're playtesting, you might even find that people will sit with a video camera to watch somebody play the game. Well, that's one person. So anybody who wants to turn around and say, oh, well, analytics doesn't have statistical significance when they also want to watch one person play the game, kind of needs to shut the fuck up. You'll be able to learn a whole bunch more about this at my GCAP talk on Wednesday. It's going to be in room 10, which I guess is next door, at 12, and that's going to be data science on an indie budget. And that's me. So back to Mark for some future of Unity analytics.
Thanks, Luke. Yeah. Because that was fucking awesome, right? We've rehearsed this several times, and I'm always blown away by it. It's really cool. I wanted to just wrap up. We'll leave a little time at the end for questions, but I wanted to just talk a little bit about some things that we're doing going forward. And some of that has some synergies with some of the stuff Luke was talking about, and certainly recalls back to some of the stuff that I said at the beginning. So, what we're shooting for, like if you were to come in and talk with my boss, and after the whiskey and after we'd partied for a while, we're working on something called adaptive gaming. This is our vision, and the idea of adaptive gaming is to say that your game should, to the extent possible, just work, right? You shouldn't have to do a lot of data science. You shouldn't have to go through doing funnels. You shouldn't have to do all the things that make you guys, for most of you, I suspect, your profession is making games, and that's what you want to focus on. Now, there are some people in the audience probably who are analytics folks, and they love number crunching, and that's great, and we should work for you too. But I think an awful lot of you, I suspect, this has certainly been true of conferences I've been to, people I've spoken to, they just want to make their games and kind of have them be big and successful and then make another game and like that. So I can't replace your creativity, and I'm not going to try to, but what I can do is I can imagine a future in which your game, we can kind of tune your game to be the best version of itself, right? And being the best version of itself might mean things like your game would work on any device, right? You release a game, you kind of want it to work on all the devices without you having to do a lot of stuff or cut off a lot of devices because it doesn't work. It would be nice perhaps if it adapted itself to the player and what the player, so if you have the 4 Bartle types that Luke was describing, or maybe clusters that do other things that we could identify for you and then adapt accordingly to the way that player wants to play without you having to do all the work, right? And eventually maybe, and now I'm getting just a little science fiction, to a point where it's adaptive to the granularity of an individual player. Like you show up and, hardcore player, social player, only loves things made in Australia. I don't know, but whatever the things are that you care about, that we kind of maybe know just enough about the player to be able to kind of hint you towards those sorts of solutions. So with that in mind, that's sort of long-term where we're heading, right? And you think about that loop and ways we could automate that loop or improve the pieces of it, and you maybe start to get an inkling of what I'm thinking of. But very much more concretely than that, these are specific initiatives that we're pursuing in the next year. And the reason I want you to see these in part is I want you to come up afterwards and say, hey, Mark, I'm really interested in one of these. I'd love to maybe be part of a pilot program, or I'd like to be somebody who helps form up the product. And then I will talk to you, I can talk to you at least at some level about any of these, but we have different product managers who know more than I do on some of these. So we're going to be working on an A/B testing tool. That is an obvious extension of remote settings, right? The ability to serve up to different groups, pick the one that's working best, and promote that. LiveTune is this really interesting product. I mentioned before about adapting to devices. Wouldn't it be nice if every game worked on every device, and that could just sort of work? That's sort of the dream that LiveTune is pursuing. We're in a fairly early stage with it, but the idea of it is you'd be able to sort of build in the idea of what a high-performance device would do versus a low-performance device, and then let's say the particles on a super low-end device just wouldn't happen at all. Medium device, maybe you get low-end, mini particles, and then on the high-end device, it's in its full glory, right? And imagine that for the bundles you download, for the rendering size of the textures, anything performance related, to trying to tune that for the device. And the thing is, we know a lot about devices, right? We literally have more Android device data in China than Google has. That is not an exaggeration, this is true. And because of that information, we can eventually, I'm not saying we're doing this today, and we may take a while before we get there, but we believe we can get to a point where somebody shows up with your game on a device that your game has never seen before, but we've seen it before, and we can probably make a pretty good guess as to what the settings should be for the quality settings. Playtesting service. Do we want playtesters? Is that helpful? If we could arrange a playtesting service, somebody at the back seems to. Oh, that's my 5-minute mark. Oh dear, okay. He's like, I do. Okay, so playtesting service. So we're standing up a playtesting service to see if that's a thing y'all want. Game difficulty optimization is basically, we're putting together a bunch of the tools that I showed you, remote settings, standard events, funnels, a couple of other things into a way to help you optimize your game difficulty against retention. So basically get the best retention by improving your game difficulty. Now this last one I really want to just take, I just want to emphasize it because this is the one that I care about the most. Data bindings. I think remote settings is awesome. I think it solves a problem, but I think it solves a corner of the problem. The real problem isn't how do I update data after the game has been released. It's how do I get data out of that spreadsheet or whatever into Unity. And then that same system should work to the cloud. So you release your game, you forgot to do all your achievements, you missed a few, you add some achievements. You want a new language, you add a language. You want to manage your game difficulty, you manage it, and the game just reacts. And it shouldn't be an impediment that you have to go through the App Store to do things, right? So that's something I'm super stoked about, and if you want to talk about that, I really want to talk to you, okay?
He really does.
I really, really do. Can you tell? I'm being cool about it, but I really care. Okay, that's sort of the future we're going. Thank you guys very much. We have a few minutes for questions if anybody has any. Thank you, it's been great. Now, I guess we don't have a microphone for questions? No mic, so just shout it and I'll repeat it.
With respect to the data binding question, if we are making a game around that equation, would that mean the game will increase in size? Like, if we are considering all these things that the game can adapt and
Right.
things like that?
So basically, would data bindings cause a massive increase in the binary size? I don't believe so, because it's the same data you'd have in the game anyway. It's just that now you'd have the ability to update it on the fly. I can talk to you about like how those moving parts work, or we imagine them working, but in principle, it shouldn't change the binary size. I mean, maybe a little to declare the binding, but like a trivial amount of increase. Anyone else? Well, okay, again, let me be very clear. Data bindings doesn't exist yet. Yeah, so essentially anything that you would routinely put into a spreadsheet. So same sort of stuff that's in remote settings, strings, numbers, bools.
Question for Luke. About the clustering. I'm kind of fascinated by how the clustering kind of works under the hood, but in a more practical sense, you talk about the dimensionality of the data, and you talk about how you want to turn them into segments instead of in the analytics. I'm still struggling to have like a practical example of like, here's a cluster, here's all the dimensions which it's across. How do you act on that?
So, good question. I was kind of trying to arm wave this one away. So Mark gave me 1.2 gigabytes of level complete data. Would not have been my first choice, but when he sent it to me, I was in Fiji, and I was just like, okay, I'm not arguing, I'm just going to make it work. So the way that you would kind of go about making it all come together is probably to have a richer data set, logging or using a bunch of different counters, and then you would have like, imagine that you have a counter for the number of different social interactions, for example. So there's gifting, there's chat, there's this, there's that, there's the other. You also have like counters about how many battles somebody's taking, for example, or they're doing this, that, and the other. So you're going to end up with a rich data set of a very still high dimension data set that you're not going to be able to cluster yourself. The way that you would act on that is then to kind of, the clustering is going to give you, so the way that the k-means clustering works is to get, and this is going to be a very technical answer, but you get to center point of the cluster. So you've got a center, if you imagine that in every dimension that you have a center point here, center point here, center point here, and then on the next dimension it might be here, here, and here. But that allows you then to say, okay, well, we can make a cut on this dimension and say, if you are less than this, then you're in this one, and if you're more than this, then you're in this one. So that's how you would implement it. So what you end up with is a world where you can say, and this is going to sound very naive and trivial, but you can say somebody who chats more than 50 times a day and gifts less than 3 times a day and battles more than 50 times a day and is this kind of player. And as a result of that, what we're going to do is we're going to give them this type of experience. So, for example, to come back to the battle player types, and this is kind of why it was there to kind of signpost this kind of thing, somebody who is a socializer, maybe they are providing connective tissue that is holding the game together. They're providing that kind of social interaction to a bunch of people. So do you want them, is there value to you that they pay for the game? Probably isn't. It's probably that they continue to play. So you might give them something kind of reward maybe to say, hey, keep playing our game. It's more about understanding the kinds of players that you have and then tailoring the experience to them. I mean, Mark is kind of chasing the holy grail when he says tailored at the individual level. Right now, what I'm talking about is kind of finding ways to abstract away from individuality in a more meaningful way than just kind of payer, non-payer. It's about kind of being more organic and about what's happening in the game to get to that kind of assessment. And I hope that answered the question because I'm pretty sure we're... Cool. Okay. We are out of time.
I think we're out of time. If you have any more questions, we'll be outside.
Yeah, we'll
and if you want to talk about any of those topics, please come find me.
Believe me, Mark really wants to talk about those topics.
Thank you, everyone.